Fashion Tech Alliance involves higher educational institutions, small, medium and big enterprises and the research center. This project has been co-founded by the Erasmus Plus program of the European Union and is aimed to facilitate knowledge exchange between partners and to design and pilot learning experiences to engage students in a fashion tech residency program, embedding young talents in the company's innovation activities. A central objective of the project is to design multidisciplinary, interdisciplinary and intersectoral learning activities involving international students from 5 European universities. The contents of the lectures have been specifically created to match the needs of fashion tech learning. They have become open educational resources to allow future engagement between a European-wide fashion and textile HEI community and are available under Creative Commons Sharealike 4.0 with the aim of a wide and free distribution, access, use and reuse. Ready to learn more about fashion tech? Enjoy the lecture.
Hello, my name is Douglas Atkinson and I'm a lecturer in wearable technology at London College of Fashion. In this lecture, I'm going to discuss various methods for capturing body data. This is really important to fashion tech in several ways. Not only can it help us to understand more about our body, it can help us to create interactions with the body, but it can also help with marketing and help with understanding consumer behavior. It can help with things such as sizing, and all of this can be captured through various kinds of sensors and methods. So this lecture will hopefully give you an overview of some of the technologies and their potentials. The lecture will be structured in 3 main sections. First, discussing health and physiological sensing technologies. And these are some of the body-based sensing technologies we'll be most familiar with, because they're often found in the kinds of wearables that we may own already or that we may at least have engaged with in the past. Next, moving on to a slightly different level, I'm going to discuss sensors that are capable of tracking or at least inferring emotions, intentions and thoughts. And these are some more medical technologies that are at the early stages of being incorporated into wearable items. So these include things like skin galvanics, measurement of posture and measurement of brain activity with EEG. And then finally, in the last section of the lecture, I'm going to consider whether we actually need to place sensors on the body and whether we can understand a lot about the body and about all of the factors that as fashion designers we might want to understand remotely using different technologies that may be imaging based. So to question the idea, particularly of wearable technology, as necessarily being carrier of sensors and sensing systems on the body. So, you may already have guessed what the answer to this question will be, but to open this lecture, I would like to pose the question of what data from fitness trackers, from medical sensors, and from in-store CCTV actually have in common. And in case you haven't guessed this already, it's the amount that they can tell you about our body. And you might be surprised by the end of the lecture to learn just how in-depth some of that can be, even from CCTV. So, to open the lecture, I'm going to talk a little bit about health and physiological sensing technologies. These are technologies that feature in a lot of fitness tracking devices. So if you own, for example, an Apple Watch or a Fitbit, these are the technologies that will probably be familiar to you. They're fairly domesticated technologies that we see quite commonly every day. Now, having mentioned fitness trackers that sit on the wrist, I thought I would show you a slightly different version of the same technology. This is a ring by a Finnish company called Aura, and it contains almost exactly the same sensors as you would find on a wrist-mounted fitness tracker. So it can sense movement, it can sense your heart rate, and it can also sense temperature. And in a study that they conducted in 2020, they actually discovered that using the temperature readings for a completely different purpose than they were originally included in the ring, they were able to show COVID infection before symptoms actually appeared. So sometimes with a device, even that's intended to track your health and your fitness as a sports person, as someone who might be interested in running or walking more, there are metrics that you can infer from their data that can tell you completely different things. And that's something to be aware of, especially in terms of the ethics of capturing data from these devices. So, how does an Aura smart ring or an Apple Watch work? Well, they include a few core technologies, and this image is an example of an Arduino-based version of one of those technologies, and it's an optical pulse sensor. So in the image of the smart ring, you might have noticed the kind of bumps with LEDs inside them, and you may have seen that as well on Apple Watches and other devices. So those are optical pulse sensors. And really what they do is they use LEDs to actually shine light into the body and to measure how much of that light is reflected back. And what that can do is to actually measure the blood flow through the body. Because if you imagine when your blood is pulsing through a vein or through a capillary close to the surface, it changes the reflectance, the amount of light that's reflected back. And so that's a very simple way of measuring your pulse and your heart rate. And that's how a lot of wearable technology sensors work. Now, alongside these optical sensors, another really crucial technology is accelerometers. And we're quite familiar with accelerometers. You may not know the name for them, but they're the technology that senses a position in space. And an easy example of how they work and where you might have seen them before is they're the sensor that can tell you if your phone or your tablet is tilted. So it can tell you the orientation and adapt the screen layout accordingly. But crucially, they work in more than just 2 dimensions. So they work in 3-dimensional space and can measure movement along very many different axes depending on the sensitivity of the accelerometer. But at least in the minimum, the 3 axes that are usually used to measure 3-dimensional space. So those are the 2 core technologies. Then temperature is another very common technology in all of these fitness tracking devices. And finally, there are some that include activity such as muscle activity and sweat, which in fitness trackers are used to indicate how hard you're working, how much of a workout you're having, and how much you sweat. But actually, these are measured through electrical conductivity quite often and can be used to read other metrics from the body. And I'm going to talk about those in a little while. So, all of these different sensors, although they're a fairly basic set, can be combined together to find out more about the body, like the example I mentioned with the temperature readings exploring kind of COVID exposure. There are future developments that are being worked on, including using optical sensors to develop blood sugar levels. And there are ways that all of these sensor readings work together. So, for example, movement and pulse rate can tell you whether your pulse should be high if you're exercising, if you're working out, or whether perhaps actually your pulse is unusually high and you're not moving, you're not doing any kind of activity, which would indicate a medical problem. So, because these are quite capable of indicating medical issues, there is controversy around the ethics of taking all of this data. There are even health insurance companies that provide 3 free fitness trackers when you sign up for a kind of insurance policy. And they make it a criteria that you will measure and track your fitness with one of them. Now, this can be good and bad because although it allows people to be more aware of their own health, it also means that sometimes people can be excluded, people can be forced into self-monitoring or potentially to revealing conditions that they might not even have known they had through data that can be analysed from the wearable. So there are pros and cons to the use of these kind of physiological and fitness tracking ideas. But they can also be used to trigger interactions and to create positive experiences or fun experiences. And I'm going to talk about some kind of fashion interaction pieces later on in the lecture. Now, one application where these kinds of sensors is really useful is when it's very difficult to monitor your health or to have access to doctors. And this was an application that was tested by a company called Hexoskin, who make health monitoring garments, and in this case there's a vest that you can see there and also a kind of brain activity monitor. Now the vest goes slightly further than some of the wrist-worn wearables in that it includes a band around the chest to measure breathing and to measure heart rate closer to the source by including a heart rate sensor close to the chest. So these have been tested in the kind of astroskin outfits that they've created for the International Space Station, but they're also available commercially and often quite readily adopted by performance athletes and by athletes who want to train to the best of their ability. So far, mostly these kinds of technologies have found applications in sports and in medicine. There are some really interesting future developments taking place, however, that are worth noting. For example, in the case of the Somea Research Group at the University of Tokyo, exploring the idea of creating skin-like wearables, and so creating sensors and displays that act as just a film on the body. So if you imagine in this image, we have a display that's showing the heart rate of the wearer on the back of their hand. The end goal is to create skin-like substances that can be applied to the body anywhere and have sensing capacities to monitor healthcare metrics. Now, there are several research groups working on similar technologies, and there's an interesting project at the University of Colorado Boulder, which actually is investigating an electronic skin that's both self-healing and fully recyclable, using particular materials to make end-of-life disassembly as frictionless and as easy as possible, and solving some of the issues that are quite common to wearable tech products in terms of the integration of different waste streams. Now, the next section of this lecture is going to explore some slightly more unusual metrics, again, partly through health contexts and partly in terms of consumer contexts. And these are the measurements of emotion, intention, and thoughts. And these are not as easily inferred as you might think. So far, no one can read your mind with a technology, but they can discover quite a bit about what kind of reaction you're having to something. So one of these technologies is based around the fairly old-fashioned idea of a lie detector test. And it brings into question whether it's possible to read truthfulness or stress from a wearable sensor. And the technology it uses is called galvanic skin response. And that's one of the key components of a lie detector test, which is used in conjunction with other metrics. Now, earlier I mentioned that sweat and the electrical conductivity of the skin was sometimes used in fitness trackers. That's the same technology. So galvanic skin response measures very, very tiny amounts of change in the electrical current of the skin based on how much you sweat. And usually it can be inferred whether or not you're under stress from the amount that you sweat. And that's why it's used in lie detector tests. So the classic polygraph test. And that relies on combined input, which is the sweat and the heart rate. So skin response, heart rate, and sometimes other metrics. But galvanic skin response has other uses as well. It's been made into commercial devices, particularly to give people early warnings of epileptic seizures. This is a company called Empatica, which sells skin galvanic response monitoring bracelets. And they were able to actually use the data that they captured from these devices to understand whether someone was likely to have an epileptic fit and to provide them with early warning of a seizure. So again, medical applications. But as we move on to other devices, again working with like electrical measurements, we start to see more applications in gaming. So this is an EMG, or Electromyogram Bracelet, and it was designed really as a research tool. It's from a company called Thalmic Labs, and it's no longer available, but it was used in quite a lot of research in interfaces and in gaming particularly, because what it does is it measures the electrical activity in the muscles of your arm. So it's worn around your forearm. For example, if I were to grasp something, this could measure that action and translate it into a virtual environment. And so as a way of capturing gesture, it has obvious applications for gaming. It's not in consumer devices yet, but Amazon did buy it out, so watch this space. You might be able to have these kinds of gesture-based interfaces sooner than you think. But it's also interesting in terms of inclusive design, because it can read the intention to cause a gesture. So for people who have lost limbs, it can be linked to prosthetics, and the electrical signals that register the intention to grasp something can be used to activate the prosthetic. So not only does it have the gaming application as a kind of novelty and as a fun interface, but it also has a real social benefit potentially. So other research has explored its use in musical interfaces and these ideas of capturing movement. So that's quite an interesting one, and it can be used in creative experience design as well. Now, if we're talking about electrical mapping, another really well-known device is EEG, and the very long technical term for that is electroencephalogram. But all you need to know is that EEG is the measurement of brain activity through electrical signals. And you've probably seen images of this kind of EEG cap, which have multiple data channels, and they can actually have up to 256 data channels. So they can really quite finely measure the electrical activity in the brain. They're often used in psychology studies, so this is where we start to see an influence in marketing and retail, because there is a whole branch of marketing known as neuromarketing, which actually maps people's brain response to marketing material. However, again, it's worth stressing that this can't read your thoughts. So I was involved in a project that was using EEG to try and see if we could map people's understanding of perceptions of fabric surfaces. So perceptions of roughness, smoothness, all the different qualities that help you to understand how a fabric feels. And this was approximately sort of 10 years ago now, so the technology may have caught up. But at that time, we didn't have enough of an understanding of how the brain mapped information like these sensory experiences to say for sure whether we were seeing people feeling something that was rough or smooth. We could map pleasant and unpleasant touch, but the difference between smooth, rough, furry, silky, at that point in time, we didn't understand the brain well enough to be able to map that accurately. So none of these devices can quite read your thoughts. What they are good at is understanding whether you're focusing on something, whether you might be stressed, or whether you're having a heightened emotional response. So again, with the skin galvanic sensing, it can tell you whether you're under stress or whether you're having an extreme emotional response. It can't tell you what that emotional response is. So there's a lot of understanding that you can gain about the body, particularly in relation to these ideas of marketing and how we relate to products. There have even been studies using similar technologies to explore people's response to images of products like shoes and handbags in people who actually have an addiction to shopping. And they have been shown to activate the same areas of the brain as addictions to other kind of more commonly known substances like heroin and alcohol that cause serious addictive problems. So interesting comparisons in relation to what we can understand from the brain and how it relates to the behaviors we're actually asked to engage in when we're shopping and when we're being sold to. Now, this is a much more slimmed down commercial wearable tech device, but it uses the same technology. So again, it works with EEG. It's the Muse S headband, and the idea is that it can be used for sleep tracking and to measure your focus, to try and train yourself to focus further. With some of these commercial EEG devices, there is a controversy around the number of channels they use. So I mentioned the full EEG caps use lots and lots of channels to measure brain activity. In some of these smaller devices that are just a headband, generally you'll find maybe 4 to 6 channels measuring the electrical activity. And there's an additional problem in that anything mounted on the forehead can also read the electrical activity of muscles in your forehead when you frown. So they can be less reliable. However, they are starting to find their way into a lot of commercial wearable tech. As yet, the question is whether this is really a valuable application of wearable tech or whether it's a novelty. But the trickle down is happening, and it's interesting to see how it informs people's design processes, and the idea of particularly mapping focus, mapping sleep, or mapping perhaps an area of the brain that's being activated is useful or is being turned into commercial products. However, some people might say that this is tech taken to an extreme, and that we don't really need to track our brain activity to engage in guided meditation. There are some interesting examples as well of how EEG has been linked to garments. This is a piece that was created by a London design studio called The Unseen, who specialise in LCD-based inks and actually connecting these inks to computer data so that they can visualise different things. In this case, this garment was actually linked to EEG data, and the electrical activity was then used to produce different coloured effects in the LCD ink. And according to people who visited the installation where this was exhibited, various people actually had very different displayed characteristics in the ink designs. So they found that they were able to map a difference in people's kind of brain activity onto this garment. And there's more technical detail that you can find on their website and in some of the press releases around how they did that and how they actually mapped particular channels in the electrical activity of the brain to particular ink colours to produce the visual effect. So, having talked about a lot of these kind of very medical seeming wearable devices, this is an area where they start to translate into display and into more performative interactions with worn objects. And this is something we're starting to see for every single one of the technologies I have discussed with you. So from body-based sensors, from understanding our body's response to something and our physiology, we can create interesting and engaging fashion interactions. But do we need to use sensors on the body to understand all of these things? So, to problematize this area, there are lots and lots of remote sensing technologies now that are becoming more and more accomplished as computer vision technologies develop. And these are primarily visual technologies that are used to remotely sense the body. So, one obvious example that has an application in fashion tech is body scanning. And body scanning has advanced quite a long way over the years and is now actually reasonably accurate from mobile phones. So companies like 3D Look offer their mobile tailor app, which can be used to take a remote body scan of customers and then fed into either a kind of development process for bespoke garments or used to assess the best fit or give size recommendations. Previously, to get a really accurate scan would have taken either an array setup where you use photogrammetry or where you use multiple depth cameras. But that's actually changing, although those are still the gold standard for being able to resolve a very, very high fidelity body scan that might give you data accurate to the millimeter. Now, do we need a device to do this for us? Or potentially, could this happen to us in our daily lives? This particular example, and it may look innocent at first, is an example of the level of computer vision technologies being applied to retail experience. And this is an Amazon Fresh grocery store. And there are several opening throughout the world now, including in London. And the most interesting part of this image is not the groceries, but it's if you look at the ceiling. And you notice the amount of different cameras mounted there. You can fairly easily infer that these are all depth cameras. And if you look at how many of them, this is how they get a very accurate resolution of the movements of people in the store. So they can see what you pick up. And if you've never heard of the concept of an Amazon Fresh store, the idea is that when you enter the store, you log in with a QR code that's associated with your Amazon account. and you don't actually check out in a conventional way. You simply add things to your basket and you walk out of the store at the end. And what all of these cameras are doing are measuring where you take items from, what those items look like, whether they stay in your basket or you put them back on the shelf. And all of this data that's being captured is using a very similar technology to the technologies that would be used for body scanning. So if we think about the potential future application of this level of computer vision technology, if we put these same amounts of sensors into a garment retail store, there's no reason that we couldn't have life-size recommendations from a scan taken of you as you move through the store. Obviously, there are also ethical considerations to this, given that to shop in an Amazon fresh grocery store, you will be giving all of your account details from your Amazon account, and you'll be matching them to all of the data that they can track from these depth cameras that relate to your body, your movements, and the way you might kind of engage with the products. So a lot more personal data that identifies you is suddenly captured in this retail experience. Another similar technology that's often publicized and has a lot of discussions is face tracking technology. And this is quite widely implemented to different degrees in different places. If you own an iPhone, for example, you might use it to unlock your phone. If you come from China, you might use your face to pay for goods rather than even using a phone or a card. So there are some benefits to face tracking technologies. And in this video, there's a clear example of a creative fashion application of this kind of technology. I'm going to let this play for a little while. And while you watch, I'd like you to consider some of the potential negatives. So, as many people know, face tracking technology has some serious issues in relation to skin tone. It's quite famous for being less reliable for people with darker skin. It generally is used to map points of light and shade and bone structure, and requires quite high contrast. And all of this in the technology development reflects the fact that it was largely created by Western pale-skinned people. It's also better at recognizing men than women, which reflects a general bias in terms of gender and technology development. So, when thinking about this, you can start to understand some of the inbuilt biases that can be built into a sensor. And this can happen with all kinds of sensing technologies, but it's particularly troubling with visual sensing technologies. So, for example, another controversial piece of research was a scientist who claimed to be able to use face tracking and facial mapping to identify someone's sexuality. And this is a scientist who presented this research to the Russian government, which obviously has very troubling ethical implications. So, there are pros and there are cons to using face tracking, but one of the things that it can capture very accurately is emotion. So if you think about how expressive the human face is, emotions can be quite easily read from looking at the movement of our eyebrows, our eyes, our mouth, and our forehead. And sometimes that can be more accurate than some of the emotion tracking body-based sensors. So whereas skin galvanics might be able to tell you you're having a strong emotional response, it won't tell you what. But your face will quite easily convey whether you're having a positive or a negative experience. So face tracking can be used to actually understand your response to either an interactive experience or a product. If we think back to the Amazon example, if we add face tracking to the tracking of our movements, potentially in store it's very easy to understand our response to a fashion item or to something that we're browsing on the shelf. We don't need to even think about whether we pick it up and put it down. We can just read our facial response. So, another example of how computer vision can be used to read emotion involves mapping posture. And this example comes from a project that was conducted at UCL's Interaction Design Center. And it was using, again, depth cameras to explore how movement might be able to demonstrate whether someone was paying attention, whether someone was engaged with an activity or a thing that they were viewing, or whether they were in pain or experiencing negative emotions. And on the basis of this project, UCL actually developed a digitally captured posture library, which could then be cross-referenced against other data. And taking this even further, there are now companies who explore not just your posture, but your movement. And in particular, this technology is called gait recognition. So your gait is the way that you walk, the way that you hold your body. And in theory, this can identify you from any angle. It doesn't need to see your face. And it can be as accurate as your fingerprint, because apparently we move in such individually specific ways that it has that level of accuracy. So again, perhaps a really beneficial technology to identify you and to assign perhaps personalized recommendations in store, or even to kind of identify you and to link your emotional response to something. But again, given that it can be this powerful, there are also all sorts of ethical issues around whether people should be tracked to this level. If it's so individually specific that it's impossible to evade, is it right to be using this technology in public places? Moving even further into what you can understand from simply computer vision, there are now studies that have been recently published that are exploring the use of commercially available mobile cameras to read infrared data from the head and from the scalp, which can actually imply brain activity. So the use of the infrared reading measures temperature in very microscopic levels across the head, which can be associated with changes in activity of the brain in different areas. So this is almost, although not quite as well developed, a similar type of technology to EEG. This is very, very early stages, but it is being developed and could potentially have similar application. So with all of these things, we can start to understand an awful lot about people in a retail context. Largely, I talk about retail contexts because it's very rare that outside of a public space, we will be this tracked by visual technologies. So that's potentially an example of where a body-based sensor compared to a visual sensor have different roles in the fashion tech world. And it talks to the need perhaps for body-based sensors for people who might be in the home, for people who might be outside of the public realm, or away from a very widely monitored visual network. So although in store we can test people's intention to buy, if people are stressed and looking to impulse buy, or whether a garment makes them excited, we can also use some of these metrics in the home. We can try and understand people's emotional responses to something that might be far more fun and less sinister from a marketing perspective, and could control an interaction rather than just simply being used as data to market from. And I've used this retail context quite a lot, but also another level of thinking about this data usage is to understand what retailers and tech companies already know about your body and about your preferences, not only in relation to fashion, but in relation to all sorts of things. And the fact that actually we give away sometimes far more telling data than all of the examples I've just given you, simply by sharing our internet search histories. So as a search engine, it's possible to capture incredible amounts of detail about what we're interested in and about our preferences. If we Google symptoms of something we may be experiencing, we can start to understand things about our health. If we type in something to do with how we're feeling, we can start to understand our emotions. And we very certainly can understand shopping preferences. So do we still need sensors on the body? Is there a role where there's still a function for something that won't be captured by our search histories, and might not be captured by public realm cameras. Where does that wearable technology, that wearable sensor, really have a meaningful role anymore? So can we dematerialize fashion tech and take it away from on-body sensors and on-body devices? And in what contexts do we need to maintain those? So to conclude the lecture, I want you to think about what data you could capture from or about the body. How are you going to use it? Does it trigger an interaction with the body? In which case, how closely does it need to map to the body and to the things that you're doing? Does it need the fidelity of an on-body sensor? Does it identify an individual? So is it worth identifying someone for the benefits of this interaction or this data that's captured? What do they gain from sacrificing their potential anonymity and from sharing the data? As I've mentioned, there's a fundamental question of whether a garment or accessory needs to contain sensors. And if you've already watched my lecture on the Internet of Things and things-centered methods, this ties in with the question of whether wearable items need to contain processing power and need to be computational in their own right. So thinking about that, what can you only learn from body-based sensors? What other sensor alternatives are there, and what context are they used in? And finally, what is the role of a wearable if it doesn't capture body data? And how, intelligently and perhaps anonymously, could it trigger an interaction? So these are really important design questions that tie into our rights to anonymity and ethics, but also how to design an interactive experience that's really positive and doesn't involve the user sacrificing any kind of data or anonymity. On that note, with plenty to think about in terms of designing systems and data capture, I'm going to leave you and thank you for watching this lecture. Goodbye.